Hey everyone, I am very excited for today because today we have done it. Every single floor having a unique layout. So if I go into Unlit, you could see every floor here has a unique layout and every single wall has a door that we can go in and go into every single area of this multi-story building. We could specify how many floors we have and it will automatically adjust to it. So what we do is set the number of floors, regenerate it, and it is done. It has put in a new floor layout for each one that is unique for you to explore and do with it as you wish. And before we get into it, I just want to mention, I have started a Discord channel, so you can go ahead and join it if you're interested in just talking to fellow members of the community, asking any questions you have and the like. And I have also set up a Patreon. So if you're interested in kind of what is going on, but you're having trouble following it, I have added project files from all the tutorials I have done, or at least all of them that I could find, to the Patreon page there. So including this right here, what we're going over today, is available as a project file for you to open up, dig in, and dissect as much as you'd like, or just use as is in your projects. And the links for which are down below, of course. With that, let's get into it. Here we are back in our project. And this is where we left off, where every time we moved it, it had some issues. As you can see, we have gaps here. We have occasionally it spawns a wall somewhere we don't want, like that, when it can't find a proper wall option. So we're going to be fixing all of that today. Let's go ahead and open up our blueprint. This is our interior walls blueprint, and we're going to start off with changing our condition check. Now, this is where I began, and I started playing around with these values because from our result, it was always inconsistent in the side it picked, and it just gave me odd results. So after playing around with stuff, I found a slightly better version of it. So all we have to do is change this one for greater and this one for less than. So I'm going to just grab ourselves a greater than, and I'm going to hold Control and just swap out these 2 points. This one for greater and this one for less than. Just like that. We're going to plug it in. And so we're left with this. Great. Now in our calculate distance, I'm also going to swap wall A and wall B. Now you can do it this way, or what you can do is on the right here, when it's greater than, you just add to B versus add to A. So you could swap one or you can swap the other, whatever you prefer in terms of cleanliness. The result is the same. Now this maintains A over B versus B over A. For myself, I'll go ahead and keep it as it was here. I'll keep A on top, B on the bottom, and just swap out the B over A and swap these around, just like that. Great. So now if we take a look at our building and we start regenerating them, you can already see that our gap is mostly gone. It pretty much is gone at all times. Now, is it perfect in terms of the side it picks? I'd say it's not 100% perfect, right? Because it just created this edge, but it then extended this way, but it should have extended this way. This still needs to be fixed, of course. In most times, it has picked correctly here, it picked correctly here. More often than not, it does do it correctly, so this is going to be just fine for us. The next place we're going to adjust is right over here, this wall segment. If it's not equal to 1, as in if we have more than one wall segment, then it does all of this. But the problem with this is if it has 2 wall segments, I don't want it to go and do this on the first wall, right? So what we're going to do is grab this wall spawn index, get wall spawn index, and it is also going to be checked that it is not the first one. So assuming that both of these are going to be true, and we can do that with an AND Boolean, assuming both of these are going to be true, then it is going to go ahead and do the above. We're also going to simplify some of these. So we're going to be changing up a lot of this, not all of it, but a good amount of it. And we're going to change up how we're doing this section. But to begin with, what I want to do is if we go to our actual PCG graph, we're using this density remap to take all our points from 0 to 1, just to set them to 0 from the start. I want to get rid of this node and I want to build it into our generator. So that way we don't need an extra node just to use it. In here, in our graph, we need to add it right before this wall segments. So I'm going to take all of this before it, and I'm just going to drag it to the left. And what we need to do is basically go through every single point and set its value to 0 from the get-go. Now to do that is relatively simple. All we do is grab our PCG points, and we're doing a for each loop. Now for each of the points, we need to go ahead and just set the members in the array. So I'm just going to go over here to the set member points and set array. I'm going to take all of this, move it to this over and duplicate it. And I can just plug this in. And then our array index goes into our index, and our array element goes into our struct ref. And the only thing we need to change here is set our density to 0. So it's going to go through every single point here. It's going to set every single point's density to 0. And then it is going to continue from completed, and we can go ahead and plug it into the continuation here. And effectively what this does is it bypasses this. So if I go ahead and compile this, I can go ahead and just remove this density remap node, plug it in, and if I regenerate it, you could see it is still all working correctly. One less node to require. That is great news for us. I'll go ahead and delete it right away and scooch it over. Now let's go ahead and fix that error where we occasionally get the extra door, right? We occasionally get a position where it cannot spawn things correctly, which is why we sometimes get that floating door, or rather floating wall. There it is. So we got our floating piece. It's right there because it has set it up where it is trying to generate 3 walls, and it has generated 1 and 2, but our third wall can't generate because it'll be against an edge. There's no position for it to generate from. So it has placed it at origin. So let's go ahead and fix that. To do that, what we're going to do is modify this wall segments loop. We're going to change it to a for loop with break. So if you right click and search for loop with break, and it's going to be the same way. Wall segments going to last index, the first index being 1, and I can hold control and just reattach things from the original into this new one and delete the original loop. And then our break is going to be from here. If it can't remove anything, then it can go ahead and break it. So I'll add a branch node and I'll just plug this in. So the output here is true if 1 or more items were removed. So that means if it's false, as in it can't remove anything, then we want this to stop. So this false now goes into our break. So we can plug that all the way around. And then by just adding some reroute nodes, we can make sure that this is a bit more organized. There we go. Now, after this false, we can go ahead and actually modify this section right over here, where we're actually checking if it's the furthest point and it has something inside of it. Because if it has 0, that means it has already come all the way here. So we can go ahead and actually simplify this. We can just get rid of all of this and plug this condition in directly. Now I had some ideas of how to set up the actual multi-floor structure. The original plan was to use the copy points the same way we used here from our floor spine, and just copy it to every single one of the points here, and then use that. Unfortunately, it ran into some issues when I was trying to generate the walls using that manner. So all our generation and copying of the points will continue to be inside this one node for us. So for that, what we're going to do is change up some things. And the way we're going to do this is we're going to generate a single floor. A floor is going to be generated. It's going to be randomized. It is going to be stored in a new variable, and then it's going to regenerate the next floor if we have multiple floors. So effectively, it is going to store that information into a new array and then regenerate a new floor, add the new location, and then store that. And then again, regenerate, store it, regenerate, store it. And at the end, that stored information is what we use to populate every single floor with unique levels. This way, instead of having it calculate, is it going to be on the right floor or not, we go ahead and just say, hey, it has now generated random things for every floor. Let's go ahead and use it. So let's go ahead and set that up. To do that, over here, instead of adding everything to a wall index list, I found that this has run into issues. So we're going to be changing some things. So what I'm going to do is I'm going to make, instead of an array of indexes, I'm going to make an array of points instead. So what I'm going to do is I'm going to take this structure and I'm going to just right click, promote it to a variable, a local one, because we don't need it as a global variable. And I'm going to call it door point list. And then I'm going to just delete it from here and I'm going to select it and change it to an array. Now, as I'm doing this, it is actually recalculating things in the background. So I'm going to go in here and just detach this. So in the background, as I'm modifying this and recompiling it, it does not try to regenerate anything in this environment. So that makes it a little bit easier to work with. So I'm going to take our door point list and I'm going to delete this wall index. And from here, I'm going to go ahead and add our set members in PCG point. And I'm plugging this in here. Now, of course, because we're now using this, we now need to actually modify it down here to not use wall index list, but instead use our door point list. Before we do that, let's go ahead and just take this and I'm going to duplicate it here and clear it before it enters this loop. This way, whenever we make a new floor pass, we make sure that the doors are cleared so it doesn't accidentally pick the same door on the same wall. So if you don't clear this, what will happen is if you have a wall this way and a wall this way, it can pick two doors on this wall and none on this wall. But if you clear it, then it always picks one on this wall and one on this wall. So it's up to you if you want to have it in one way or the other. We want to make it so every single wall has at least one door to get into it. So we are going to go ahead and clear it. So once we've gone ahead and cleared it, and this has run through this loop, it has made our array. What we want to do is grab a random point from there. So we can get our door point list, and I'm going to use a random array in this case. And the reason is, despite me specifying last time that this is far more random than this, because our door positioning is already randomized from the other one, this is going to get us a random enough variation. I don't need it to be truly random. If it somehow picks around the same area every time, this doesn't have any impact on the result what we have. So I'll go ahead and just use this. So we take this, and so we reuse our same variables. I'll just assign it to the random selected point. And I'll just plug it in here, and it's going to go from the completed to randomly assigning one of these points. And then we can go ahead and use this point down here. Now, I did try to use the array that we stored here to just grab a point from our PCG points, but for some odd reason, when I did it in that manner, our walls would randomly disappear. One wall would just always be blank, and then the position that we set our door to be at would be a different position, despite the index being correct. This is kind of a workaround for that. So the way we do that is we can get rid of all this. We take our PCG points and do a for each loop with break. So effectively, we're going to go through every single one of these points, and we're going to compare it against this randomly selected point. So I'll go ahead and delete this wall index and scooch this over. So we can take our array element and break it, and we can take our random selected point, and we can go ahead and break that as well. So we're going to just go ahead and see if the transforms are equal and our densities are equal. And assuming that our transforms and densities are equal, then that should be reasonably enough the same point in that case. You can, of course, go in and check if its bounds are also equal, if the colors are also equal. But because of the configuration that we have it at, assuming that these two are correct, then this should be the exact point that we have. So from here, we're going to get a branch node from our loop body. It is going to check against this. And assuming it is true, it is going to set members to our density of 0.6 and then go ahead and set the array element. Now we need to get our array index from here and plug this into our index. And then once it has found one, once it is true, it has found something, it has made it 0.6, the door has been set, we go ahead and break this loop. There's no reason for it to continue calculating the rest of the points. We know it has found it. Wonderful. So this will take care of the door. Now, we've now changed it where we're no longer using this variable here, wall index list. So we need to change this section as well now. So to make this area also easier, we're going to just grab our random point like so, plug this in here, clear all of this. And again, because this is now going to be not truly random, as we had it here, it is going to be using this random node, which does seem to have some kind of leniency in terms of how truly random it is. That is fine, because again, the original wall is completely random. So this complete randomness with somewhat randomness still gets us the pretty much random result, and I don't have to go and reuse this larger, more complex randomness in that area. Now, this is a lot cleaner, which is wonderful. Of course, we don't need to set this wall index list to be removed. Instead, we need to go ahead and take our new door point list, and we can go ahead and remove item. And the point we're going to be removing is the random point that it has selected. And we can go ahead and continue plugging in our Boolean and our execute pin from here. And the same way, if it cannot remove any more points from our door point list, it is going to break this. I'll go ahead and remove this wall index list here as well. We do not need it. And we can scooch all of this over. It seems last time I didn't plug this in. So we need to plug in our return value into our wall side because that is important. If I compile, it seems we missed something. Over here, we need to plug in our array element into our structure reference. That is important. And if we go back here and just replug this in, so we can see the actual walls being generated and we kind of regenerate these around. You can see it is now generating the walls pretty well. It's all randomized and we're not going to get any walls that are going to be just by themselves out here. If it can't generate more, it just stops. So in this case, it has picked a way where it can't generate any more. So it has gone ahead and stopped it from generating extras. But now it is going to be truly random in how many points. Great. So now we need to change it where if I increase the number of floors, if I set this to 3 floors, it is not actually copying these points upwards. So we need to go ahead and set it up where every single floor will now have a unique setup. All of this can be done in so many different ways in Unreal. I'm curious, what way would you have done the floors? How would you have it set up? Let me know in the comments below. I am very interested to finding out how you guys think. To do that, we go ahead and go into our graph and we need to expose a few variables, starting with number of floors. So I'll just add a new variable called floors. It is going to be an integer, it is going to be exposed, and it is going to be a single. It is not going to be an array. And I'm also going to add a floor height, because depending on the height of the floors, we need to move the points upwards. So this one is going to be a float because it is not necessarily going to be a whole number. So we have it working for a single floor, and effectively we need to see how many loops has it done compared to the amount of floors we have. So I'm going to go ahead and add a local variable here, and I'm just going to call it floor passes completed, and it is going to be an integer. And after it has gone through the wall segments pass and has completed it, I'm going to just increment the amount of walls it has done. The first time it completes a loop, it is going to say this value is now 1. The second time it's gone through the loop, it is 2, 3, 4, and it'll entirely depend on how many floors it has done, as the name suggests. After this, we're going to check if the amount of floors that we have selected is greater than the amount it has completed. So if, for example, I've set it up to be 4 floors and it's only completed 2, well then floors is still greater. So we want it to kind of continue doing more passes. But if the amount of floors is 4 and has completed 4, the amount of floors is no longer greater, so it will stop. So let's take care of false first, because that is the more complex one. We need to check if the number of floors is equal to 1. Because if the number of floors is equal to 1, we don't need to do a lot of very complicated stuff. So assuming it's false, we'll add another branch. And if it is actually number of floors is equal to 1, then we just need to go ahead and set points. We just set the points, and this is our kind of our final area. So if it goes through here, number of floors is 1, it has completed 1, it is going to be false, it checks that it is 1 floor, so it goes to our set points node, and that's great. For our floors, we need to remember to change the default value here to 1 as our default, and also change the slider and value range to be 1 by at least. That way, you cannot specify 0 floors. And when you do that, you can come here, and we effectively have the same result as we had before. It is generating 1 floor. Great. Now you guys have made it pretty far into the video, right? Consider hitting the like button. You're clearly liking the content. You're here still. Helps me out a lot. But let's say the number of floors is greater than 1. So what we need to do is make ourselves a new variable. I'm going to get our door point list. I'm just going to duplicate it, and I'm going to call it a PCG points collection. It is going to be the sum of every single point that we have gone through. So we're going to take it and do a for each loop. And from each of these points that we're going to be collecting, we're going to add them to our PCG point list. So I grab my PCG points and I will add the points that we have stored. I'll go ahead and add them here. Now we haven't actually stored these points as of yet. And the time where they're going to be stored is if it's going to continue with our passes through this true node. So effectively, if the number of floors is 2 or 3 and has only done 1, then floors are going to be greater, in which case it needs to store our points somewhere, which is going to be in our PCG points collection, and then continue on. So from our true, we need to take our PCG points, and I'll bring it over here, and I'm going to do a for each loop. So as always, for each of the points that we have, what we need to do is add them to our PCG points collection that we have just generated. So I'll go ahead and add a node here. So every single point that has gone through, it is going to go ahead and go through the points. Great. Now we need to also then take all of these points and move them up for our next floor. So after that, we're going to take our array element and we're going to break it. We're going to split our transform. And then from our location, we're going to add, and we can go ahead and split the second pin here. We're going to add our floor height. I'll go ahead and plug this in here. And by default, I'm going to set it to 300. And then I need to go ahead and actually set the members once again and set array elements. So I'll just come up here and go ahead and grab this, duplicate it over. And after this add node, we'll plug this in here. And instead of density, we need to set the transform. So I can uncheck density, check transform, split our transform. So that way we have the location, rotation, and scale all split up. And we can plug in our rotation directly, plug in our scale directly, and our transform, we go ahead and add this new one. And of course, our array element B will come from our for each loop, and our index will come from the for each loop. So what is this going to do? This is going to go ahead and go through every single point. It is going to add them to our storage location, and then it is going to move every single point up relative to our floor height, which in our case is hard-coded 300, but of course this is going to be an exposed variable, so we can go ahead and plug in whatever number we have down the line. After that, after it has gone ahead and moved through all of these, and it has said, okay, it has now gone through every single thing. Upon completion, we need to have it go back to the start. And we need to go back all the way to where it randomly selected a point. So from our completed, I'll go ahead and drag all the way from here to randomly selecting a point over here. And I'm just going to double click to make a few reroute nodes just to make this a little bit cleaner. But effectively, we're going back to our randomly selected point. So now it is going to once again pick a random point. It is going to go ahead and make all the points density to be 0. And then it is going to go through this entire process one more time, depending on how many walls you have. And then it will check again, is it going to be stored? Now over here, after it has added all of the PCG points to all of our collected points to the PCG points, that means this is the final thing. It didn't need to store it. It just needed to add the original ones back. From there, we go ahead and on completed, just set the points. So it goes ahead and sets the points one more time. So if I scooch this over, this does get a little bit more messy in this area, but now it should have a situation where no matter how many floors we add, it should go ahead and raise them up. So if I compile and save this, over here in our PCG graph, we have our wall segments and number of floors. So if I open this up, I can plug in the number of floors we have. And we have exposed this already. Here we have a variable called floors. So I can go ahead and come over here and get actor property and just duplicate this over, or right click, get actor property, and then just rename our property name to floors, and then plug that into floors. Our floor height is hard-coded, as was before, and our wall segments is hard-coded, but we can go ahead and expose that if we want to down the line. So I'll go ahead and close this for now. Let's change the number of wall segments to be 5, because it's fine to have more wall segments, because in our configuration, if it cannot generate a wall anymore, it is going to break out of the loop. So it'll never generate errors from this. So with this, if I go ahead and save it, and then I regenerate, right, we have one floor. And now if I set the number of floors to be 2, and then I regenerate, you could see we're now getting 2 floors. And you can see from the walls kind of poking through the floor below, it has actually gone ahead and picked a different variation. So if we go unlit, this is a different configuration than the one above. And I can go ahead and set up however many wall floors I want. So if I set it to be 4 floors tall, I can go ahead and generate a new setup for every single floor. So there's our layout for this floor. If I go down, it is a different layout. And again, every single floor has the one door per area. It still occasionally does have a gap. It is not 100% fixed, but it is a whole lot better than it used to be. And there we go. So now we have a separate thing on every single floor, a separate layout that is unique. So to get our roof back, of course, we can go ahead and just plug in our roof output into our static mesh. And there we go. I am super happy with how this actually turned out, because we now effectively can start laying out different things inside of here based on different layouts. Now, I still need to figure out how I'm going to put furniture in here. I'm not sure yet, but that is on my to-do list as well. Not to mention that we want to get exterior. We want to get some exterior pipings on here. For example, we want to get a fire escape going, as well well as a staircase on the inside that is going to not have be 1 unit wide. I want it to be 2 units wide, because if it's 1 unit wide, it's a little bit too short. So I want to do maybe a 1x2 area that clears out. And depending on how it's going to clear it out, is going to go ahead and place the stairs accordingly in whatever orientation that it is going to be appropriate. And if you're like me and you're really excited to see what's going to come soon, hit the subscribe button and ring the bell to be notified for the next video. That's pretty much it. Take care.